So welcome students. In this question you're given that A and B are two angles which satisfy these two equations. 3 sine square A plus 2 sine square B is equal to 1 and 3 sine 2A minus 2 sine 2B is equal to 0. If that is so, can you find the value of A plus 2B? So if you carefully observe the equations, the first equation is in terms of A and B. The second equation is in terms of 2A and 2B. But the information that you need to derive is in terms of 1A and 2B. So how do we analyze this? So first what I do is, I'll take the first equation. So it becomes 3 sine square A is equal to, if I send this 2 sine square B onto that side, it becomes 1 minus 2 sine square B. So what is 1 minus 2 sine square B? Which is equal to cos 2B. So I like this simplification because A is being connected with 2B, which is what I want. So my equation has become 3 sine square A is equal to cos of 2B. Now what I do is, I'll try to use the second information and see whether some simplification comes. So the second information is 3 times sine 2A is equal to 2 times sine 2B. So this is the first information, first equation. So 3 sine 2A is equal to 2 sine 2B. I'll leave 2B as such. I'll convert 2A. So 3 times sine 2A is nothing but 2 sine A cos A is equal to 2 sine 2B. So 1 2 gets cancelled. So 3 sine A cos A is equal to sine of 2B. I'll take this as my second equation. Now I'll divide the first equation with the second equation, see what I get. So if I do 1 divided by 2, so 3 and 3 gets cancelled. 1 sin A and 1 sin A gets cancelled. So you have sin A by cos A, which is equal to tan A is equal to cos 2B by sin 2B is cot 2B. So cot 2B is nothing but tan of 90 degrees minus 2B from complementary angle formulas. So this implies A is equal to 90 degrees minus 2B, and this implies A plus 2B is equal to 90 degrees, which is equal to pi by 2. So option B is the right answer.